Hey guys, welcome back. All right, we're going to start right here looking at this function. Now I'm going to ask you several questions about this function, and I want you to pause the video whenever you need to so that you can have time to answer the questions. My first question is this actually a function? I've called it a function a couple times. Is it actually a function? When I look, I see this graph does pass the vertical line test. Yes, this is a function. Next, I'm curious, what is f of d? What does f of d equal? I find d on the function, and while there's no value up here, there is a value down here. The y value corresponding to f of d is -1. Next, I'm curious, what's the limit of the function as x approaches d? Taking a look at this function, as I approach the x value of d, from the right-hand side, I see that my y value is 2. As I approach d from the left-hand side, again, my y value is 2. This point down here doesn't matter. It's all about the y value that the function is approaching from both the left and the right. And in this case, the y value is 2. Next, I want to know what's the limit of the function as x approaches b from the left. Finding b on the graph and approaching the x value of b from the left-hand side, I see that my y value is 1. Now what's the limit of the function as x approaches b from the right? Looking at the graph, finding b, approaching the x value of b from the right-hand side, we see that the y value is 3. So now what's the limit of the function as x approaches b? Hopefully you see pretty easily that because the value from the left and the value from the right do not match, the limit does not exist. I have a couple more questions, and to answer these questions, you need to know something new. You need to know that functions are allowed to approach positive infinity or negative infinity. That's okay. So knowing that, let me ask you, what is the limit of the function as x approaches c from the right? Knowing that the limit of a function can equal positive or negative infinity, I find c, I jump on the function from the right-hand side, and I run towards c from the right-hand side, and this function is going down, down, down. This function is approaching negative infinity. What's the limit of the function as x approaches c from the left? Taking a look again, here's c. We're going to approach c from the left-hand side. The function goes down, down, down. Again, we are approaching negative infinity. Therefore, the limit of the function as x approaches c is negative infinity. Let's look real quickly at the limit of the function as x approaches a. From the right-hand side, it's going down to negative infinity. From the left-hand side, it's going up to positive infinity. The limit of the function as x approaches a does not exist. So now let's take a look at this problem. What is the limit as x goes to 3 of 1 over x minus 3? To evaluate a limit, the first thing I do is substitute. And if substitution works, then cool. So I'm going to plug in the 3. I get 1 over 0. And 1 over 0 is undefined. Now thankfully, I know this function. I can quick sketch this function. And quick sketching is always an option when evaluating a limit. So I quick sketch this function. And it looks kind of like that. Now approaching an x value of 3 from the right, I jump up on the limit and I run toward the value of 3. My function's flying sky high. Jumping on the left, I run towards the value of 3. My function is dropping way down low. The limit of this function from the right is infinity. The limit of this function from the left is negative infinity. The limit of this function as x approaches 3 does not exist. And you'll also notice that there's a vertical asymptote on the function at x equals 3. But what if we didn't have a quick sketch? What if we didn't have a quick and easy picture to look at and we didn't know what this limit was? Well, I'm going to answer that question, but I need to work my way there. First, to get there, let's think of some small numbers. Let's think of, say, 2, that's a small number, and 1, that's a small number. But how about even smaller numbers, like maybe 1/2, or 1/4, or say 1/8, or 1/16? Those are very small numbers. Now, how about we go even smaller? How about, say, 1/100th, or maybe 1/1000th? You'll notice that as the denominator gets bigger, the overall number gets smaller. So let's think even smaller. How about maybe 1/1,000,000th or 1/5,000,000th? Really, really small numbers here. How about 1/infinitieth? That's maybe the smallest number that you can possibly think of. How about the very, very smallest negative number? If I just make this very, very small positive number negative, I get -1/infinitieth. If I was sharing a pizza, 1/infinitieth of my pizza is the smallest little bit of my pizza that I could possibly give you. So let's look at this problem again. When I first substitute, I know I get 1/0. I know that's called undefined. And I know because of the graph that there's a vertical asymptote on the graph at x equals 3. To deal with this limit, I'm going to break this limit into two. I'm going to break it into a right-hand limit and a left-hand limit. So I have the limit as x goes to 3 from the right of 1/x minus 3, and the limit as x goes to 3 from the left of 1/x minus 3. I'm going to evaluate these two limits separately. Remember, the concept of a limit is an approach. What y value am I approaching as I get really, really, really close to an x value of 3 in this case? Let's look at a number line. Here's 3, here's 4, here's 2, and if I'm coming from the right-hand side toward the x value of 3, I get numbers like 3.5, 3.4, 3.3, 3.2, 3.1, how about 3.01, 3.001, 3.000001? If I get really crazy close to 3, but don't actually touch 3, I'm looking at a value, say, 3.00001. That's the closest value I can get to 3 without actually touching 3. So here's the idea. I can't substitute 3 itself because it gives me an undefined value. But what if I substitute a value really, really close to 3, but not actually 3? That would look like this. 1/, and now again, a value coming at 3 from the right-hand side that's really, really close to 3, but not 3 itself, would be 3.00001. And then the problem itself had a -3. So instead of plugging in 3 itself, I plugged in a value really close to 3 coming from the right-hand side. Now if I do the subtraction on this, if I did the math, 3.0000001 minus 3, I would get 1/0.0000001. 0.00001 is a really, really small positive number. It's perhaps the smallest positive number that I could think of. It is 1/infinity. And now looking at this math, I have 1/1 divided by 1/infinity, which becomes 1/1 times infinity over 1, which equals infinity. For the function 1/x minus 3, approaching an x value of 3 from the right-hand side, we get a value of positive infinity. And we can look back real quick and see on our quick sketch that, yeah, as we approach 3 from the right-hand side, our function does fly sky high up to positive infinity. So now coming back to the problem, let's look again at a number line. Here's 3, here's 4, here's 2. Approaching the value 3 from the left-hand side, we get values like 2.5, 2.6, 2.7, 2.8, 2.9, getting closer, 2.99, getting even closer, 2.999. The closest that we can get to 3 without actually touching 3 is, say, 2.999999999. So now coming back to the problem. I can't plug in 3 exactly. That will give me an undefined value. But if I plug in a value that's really, really close to 3 from the left-hand side, say a value like 2.9999999, and then I do that math, I get 1/2.99999 minus 3 is going to give me a really, really small negative number, like negative 0.000001, which is 1/(-1/infinity. So now doing the math, I get 1/1 divided by negative 1/infinity. That's 1/1 times negative infinity over 1. I get negative infinity. So looking at the function 1/x minus 3 and approaching 3 from the left-hand side gives me the value negative infinity. And looking back, again, you can see that happening on our quick sketch. Approaching 3 from the left-hand side, the function flies way down to negative infinity. So let's take out our limit chart and make sure we're keeping track of all this. We know what to do with an indeterminate limit. But now we're going to fly way over here to the right-hand side and then cut back about halfway. This side of the limit chart deals with limits that have a number over 0. Those limits are called undefined. And an undefined limit means three things. An undefined limit means that the limit is infinite or non-existent. And 2, I must break up the limit to find it. Third, it means there is a vertical asymptote. To deal with that, I can do a couple things. The first thing I can do is factor, if it's possible. Not all problems are going to factor, but if it's possible, I'm going to factor. And second, I'm going to break the limit in two. I'm going to break it into a left-hand and a right-hand limit. After doing both of those, I'm going to use the concept of a very, very small positive number, like 1 over infinity, and a very, very small negative number, like negative 1 over infinity, to evaluate the limit. Let's go finish up that problem that we started. Starting again, to evaluate a limit, the first thing we do is substitute, and if substitution works, then cool. If substitution doesn't work, you might get a number over 0, which is called undefined. An undefined limit means three things. It means the limit is infinite or non-existent. That means that my answer is always going to be positive infinity or negative infinity, or that my limit does not exist. It also means that I must break up the limit to find it. I'm going to break it into a right-hand limit and a left-hand limit. And it means there's a vertical asymptote, and we know that the vertical asymptote is at x equals 3. The vertical asymptote is always going to be at the x value that we're approaching. So to deal with this, we're going to factor if possible. Now it's not possible to factor this limit, so we move on. We break this limit into a left and right-hand limit, which we did. And then we use the concept of a very small positive number and a very small negative number to evaluate a limit. You plug in a number for x that's very, very close to the value that we're approaching, but not exactly the value that you're approaching. And then you do the math. We got infinity from the right, we got negative infinity from the left, therefore the limit as x approaches 3 for 1 over x minus 3 does not exist. Let's take a look at another problem. Okay, so to evaluate a limit, the first thing we do is substitute, and if substitution works, then cool. So I'm going to go ahead and plug in my 4. And I get negative 2 over, that's 16 minus 8 minus 8, that is 0. A number over 0 is called undefined. And an undefined limit means three things. It means the limit is infinite or non-existent. It means I must break up the limit to find it, and it means there's a vertical asymptote. And I can find that vertical asymptote right here. The vertical asymptote is going to be at the x value that we're approaching. There's a vertical asymptote at x equals 4. To deal with the undefined limit, I'm going to factor if possible, and I'm going to break the limit in two. Break it into a left-hand limit and a right-hand limit. I can do both of those steps at the same time if I want to. I have the limit as x goes to 4 from the right of 2 minus x over x minus 4 times x plus 2. Double check your factoring just to make sure, but I double checked and I'm good. And I also have the limit as x goes to 4 from the left of 2 minus x over x minus 4 times x plus 2. Now with an indeterminate limit, the problem was the 0 over 0 term. With an undefined limit, the problem is the 0 on the bottom. You're not going to have a matching 0 on the top, and nothing else is a problem. The problem is that there is a 0 on the bottom. So we're going to go ahead and substitute into any of these terms that do not create a 0 on the bottom for us. So on the top, we have 2 minus 4. On the bottom, we can't substitute into the first term, x minus 4, because 4 minus 4 would give us the 0 on the bottom, and we need to avoid that. So I'll leave that term as it is, but plugging into this second term, I get 4 plus 2. 4 plus 2 is 6, and that's going to be just fine. So at this point, we have negative 2 over x minus 4 times 6. When evaluating an undefined limit, always substitute into any term that does not create the 0 on the bottom. And now we can use the concept of a really, really small positive number or a really, really small negative number. Looking at a number line. Here's 4, here's 5, here's 3. If I approach 4 from the right-hand side, I get numbers like 4.5, 4.3, 4.1, 4.0000001. Now I know I can't plug in 4 itself, but I can plug in a number that's really, really close to 4 and see what's happening. So I have my negative 2 on the top, and now I'm going to plug in a value really, really close to 4. I'm going to plug in 4.00001 minus 4 times 6. Now I can reduce the 2 and the 6 at any point. I'll be left with a 3 on the bottom, and don't lose the negative on the top. And I'm going to go ahead and do this subtraction. Doing that subtraction gives me 0.00001, which is a really, really, really small positive number. Another name for my really, really small positive number is 1 over infinity. So at this point, I have negative 1 over 1 over infinity times 3. So now it's just a matter of cleaning this up. I have negative 1 over 3 over infinity, so that's negative 1 over 1 divided by 3 over infinity, which becomes negative 1 over 1 times infinity over 3, so I get negative 1/3 infinity. But in the world of infinities, if you're going forever and ever and ever, what happens if I divide that value by 3? Nothing really happens. You're still going forever and ever and ever. If you think of a vertical asymptote, if you're going down, 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 it doesn't matter if you divide that by 3, you're still going down, 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 down. So the coefficient in this problem doesn't play into it, and your answer is negative infinity. That's the answer for the right-hand limit. Now we have to evaluate the left-hand limit. It plays out largely the same. We're going to go ahead and substitute in the 4 for any value that doesn't mess up the function. And we know how that goes. We go 2 minus 4 over, we can't plug into the x minus 4, but we can plug into the x plus 2. So we get negative 2 over x minus 4 times 6. And when you're evaluating an undefined limit, there's no need to redo that substitution math every time. You can go ahead and start here when you're evaluating your second limit. Now we're going to look again at our number line. As we approach 4, from the left, we get 3.5, 3.7, 3.8, 3.9. As we get closer and closer, we get 3.9999999. We get super, super close to 4, but we don't actually touch 4. And when we substitute that value in, we get a problem that looks like this. Now, just like last time, we can go ahead and reduce our fractions. That'll leave us with a 3 on the bottom, and don't lose that negative. And when we do this math here, 3.9999999 minus 4, we get an answer of negative 0.0000001, which is a really, really tiny negative number. And another way of saying a really, really small negative number is negative 1 over infinity. So that becomes negative 1 over negative 1 over infinity times 3. Simplifying that problem, we have negative 1 over negative 3 over infinity. That gives us negative 1 over 1 divided by negative 3 over infinity, which becomes negative 1 over 1 times negative infinity over 3. The negatives cancel, and we get 1/3 infinity. And just like before, the concept of 1/3 of infinity doesn't really make sense. So the answer for this side of the limit is positive infinity. So from the right, we had negative infinity. From the left, we had positive infinity. Therefore, the limit of this function as x approaches 4 does not exist. Let's take a look at another. This time we have the limit as x approaches negative 2 of x plus 5 over x plus 2 squared. To evaluate a limit, the first thing I do is substitute. So I get negative 2 plus 5 over negative 2 plus 2 squared. I end up with 3 over 0. That is an undefined limit. And an undefined limit means three things. What are they? An undefined limit means the limit is infinite or does not exist. It means I must break up the limit to find it, and there's a vertical asymptote. And to deal with that, I'm going to factor if possible, and I'm going to break this into a right and left-hand limit. Now you can write the bottom term as x plus 2 squared, or if you prefer, you can write it as x plus 2 times x plus 2. Either one of those will work out perfectly fine. It's just a matter of personal preference. Now I know that the problem with this undefined limit is the 0 on the bottom. So I'm going to go ahead and substitute into any term that does not give me a 0 on the bottom. Plugging negative 2 into the top, I get 3 on the top, and obviously it would be the same for the left-hand limit. The bottom is where we're going to have problems. If we plug in negative 2, we're going to get 0 on the bottom. So I'm going to go ahead and look at a number line. Here's negative 2. Here's negative 1, here's negative 3. Make sure you set up your number line properly. I've seen people mess up their number lines, which then obviously would mess up the entire problem. And as we approach negative 2, from the right-hand side, we get numbers like negative 1.5, negative 1.7, negative 1.8, negative 1.9, negative 1.999999999. That's as close as we're going to get to negative 2 without actually touching negative 2. So if I substitute that value in for x, and when I simplify the bottom, negative 1.99999 plus 2, I get positive 0.0000001, which is a really small positive number. So now I have 3 over 1 over infinity squared. Simplifying, that's 3 over 1 divided by 1 over infinity squared. That's going to become 3 over 1 times infinity squared over 1, which is 3 infinity squared. But again, in the world of infinities, if we're going forever and ever and ever, does multiplying by 3 really matter? No. And if we're going forever and ever and ever and ever, does squaring that value really matter? No, not when we're talking about an approach. We are approaching infinity, and that is the answer for the right-hand limit. Now coming to the left-hand limit. Looking at our number line, if we approach negative 2 from the left-hand side, we get values like negative 2.5, negative 2.3, negative 2.1, negative 2.01, negative 2.000000001. That's as close as we can get to negative 2 from the left-hand side without actually touching negative 2. So substituting that value in, and simplifying the terms on the bottom, negative 2.00001 plus 2 gives us negative 0.0000001. That's a really small negative number, a number like negative 1 over infinity. We get the same for the second term. So now we have 3 over negative 1 over infinity times negative 1 over infinity. The negative times a negative are going to cancel. We're going to have 3 over 1 over infinity squared, which is 3 over 1, divided by 1 over infinity squared, which is 3 over 1 times infinity squared over 1. Again, we get 3 infinity squared, but in terms of an approach, in terms of the value that we're moving towards, the 3 doesn't matter, the square doesn't matter. We end up with just infinity. And so, because the limit from the right equals positive infinity, the limit from the left also equals positive infinity, the limit of this function equals infinity. And we can write the limit as x goes to negative 2 of x plus 5 over x plus 2 squared equals infinity. Let's look at another problem. Let's go with the limit as x goes to negative 1 of x plus 2 times x squared minus 3x over x plus 2 times x squared minus 1. To evaluate a limit, the first thing we do is substitute. So let's see what we get. We get 4 over 0, which is undefined. And an undefined limit means three things. It means the limit is infinite or non-existent. I must break up the limit to find it, and there's a vertical asymptote. We can already know right here that our vertical asymptote is at x equals -1 because that's the value that we're approaching. And I'm going to go ahead and factor and break up the limit in the same step. So depending on the original function, there are a couple different ways that we can move forward from here. One idea to save time is to say, look, we already substituted into the top, we got out 4, so I can right here substitute into the top and get out 4. I already know what I'm going to get, so I don't have to do the work. A different idea is to see that there are matching x plus 2 over x plus 2 terms on the top and bottom. Now, if the matching terms cause 0 over 0, we would be on the other side of the limit chart. In this case, we don't get 0 over 0, and eliminating those two terms is the same as reducing a fraction. We can cancel matching terms on the top and bottom as long as those terms aren't terms that give us 0 over 0. And with an undefined limit, they won't be terms that give us 0 over 0, otherwise we'd have an indeterminate limit. So a different option is to cancel the x plus 2 over x plus 2. And depending on the problem, that might change my 4 here. For this problem it doesn't, but I'm going to pretend that it does. So this time I'm going to eliminate my x plus 2 over x plus 2, and now I'm going to substitute into anything that doesn't mess up the function. So I have -1 times -1 minus 3 over x plus 1, I can't substitute in there, but then I have -1 minus 1. Simplifying the top, I get 4 over, I have x plus 1 times -2 on the bottom. Now I'm going to look at a number line. Here's -1, here's 0, here's -2. Approaching -1 from the right-hand side gives me a number like -0.9999999, and substituting that in for x, I get 4 over -0.9999999 plus 1 times -2. So I'm going to reduce my 4 and my -2. That leaves me with a 2 on top, and don't forget the negative. Simplifying -0.99999 plus 1 gives me a really small positive number, a number that I'm going to call 1 over infinity. So now I have 2 over -1 over infinity. That's 2 over 1 divided by -1 over infinity. That's 2 over 1 times -infinity over 1. That gives me -2 times infinity. In the world of infinities, a 2 doesn't really matter, and so we end up with -infinity. Now I'm going to evaluate this limit from the left-hand side, and let's pretend that I didn't reduce the x plus 2 terms. That means that I can jump straight to the 4 on the top, because I know that substituting into this top gives me this 4. And now I'm going to substitute into anything that doesn't cause a 0 on the bottom. So I'm going to have -1 plus 2 times x plus 1 times -1 minus 1. That's 4 over 1 times x plus 1 times -2. And I'm going to multiply the two numerical terms on the bottom and simplify just a bit. I have 4 over x plus 1 times -2. I'm going to reduce my 4 and my -2. I have a 2 on top. Again, don't lose that negative. And I'm going to look at my number line again, approaching from the left-hand side, getting really close to -1. I get -1.000001. And so I'm going to plug that in for my x value. So now simplifying -1.0001 plus 1, I'm going to get a really small negative number. Multiplying -1 over infinity times -1, I end up with 2 over +1 over infinity, which gives me 2 over 1 divided by 1 over infinity, which is 2 over 1 times infinity over 1, which is 2 times infinity. And in the world of infinities, multiplying by 2, it doesn't really matter. I end up with positive infinity as I approach -1 from the left-hand side. Since our limit from the right is negative infinity and our limit from the left is positive infinity, this limit does not exist. And we would write that the limit does not exist. All right, girls and guys, thanks for watching. Let me know if you have any questions. Have a great day.